All right, so let's talk about this so-called difference quotient. It kind of ties in with what we just were talking about. All right, so let's say I've got a function f of x equals x cubed minus 4. And I want to compute what's called this difference quotient. And here's what the difference quotient is. It's function notation kind of expanded, I guess. And they'll have different versions of this or different variations of this, I guess you could say, but one of them you might see is this, f of, and then x plus h, and then minus the f of x, and then divide by h. And let me check. I didn't exactly write it all out here. But yeah, it'll be something similar to that. It may not be all that. Trying to see the ones got you assigned here. Okay. Yeah, there's just different versions. Okay. Yeah, so let's. I think it's. Okay. All right. So what you do is you compute a difference quotient for this function here. Kind of wordy. And this is the f, which I refer to here. Yeah, so it's just kind of putting some function notation stuff together on the top. So on the top we've got two functions to evaluate there, if you will, two function values to evaluate. And so just like we were saying before, all right, so this just means what? Input x plus h for the x, and so over here. So if I input that just means x plus h cubed minus 4. That's my f of x plus h. The second one's a whole lot easier because it's just minus f of x. The thing about that is, all right, there is this minus sign in front, and so f of x is this, and won't that minus then affect the x cubed minus 4? Because if I subtract f of x, that's going to mean these here are going to be opposite. So far, so good. And then, of course, the bottom is just h. There's nothing to compute there. It'll come to play here in a second. All right. Well, so yeah, if we have a cube, you may know a shortcut, but if not all else fails, you got three copies, right? X plus h, x plus h, x plus h. Just multiply all three of those out. Multiply those things out. So what do we got here? We got, you do two, hard to do all three at once, but two of them at a time. So we got x squared, then you got xh and another xh, so you got two xh's. And then you got h times h, you got h squared. And then multiply all that by x plus h. Bring that one down. So you got x cubed, this times this times this. So you got x cubed and then plus xh. All right, then do the same thing. You got 2xh times x, so that's 2x squared h. What did I do? Oh, let me redo that. Take number 2. All right. All right, so we got x squared times h, so that's x cubed. And then we got x squared times h is x squared h. Forgot the square. Then we do the 2xh times x, so that would be 2x squared h. And then 2xh times h would be 2xh squared. And then last but not least, do the h squared times x squared times h, so that would be xh squared, I write it that way, plus h cubed. And then we do have some like terms here. We got an x squared h, so here's what we wind up with. We got x cubed, then you've got 3, because that's 1, that's 2, so that's 3 x squared h's. And then we got these two xh squared, so you got 2 and 1, so that's 3 of those, 3 xh squareds, and then h. That's what this one comes out to be. And then we got the minus 4. And then you got distribute the minus, you got minus x cubed plus 4. Well, it looks bad. Things look bad. However, not so bad. Because look what happens. This happens a lot on these difference quotients. Do you see anything nice occurring here? You got an x cubed and a minus x cubed, right? Let's just wipe those out. You got a minus 4 and you got a plus 4. So all that's left on top is 3x squared h. I can't write it. 3xh squared and h cubed all over h. Yeah, but even better, we can still do some more simplifying, can't we? Because what do you see? Common factor of h on the top. All these have an h in them. This one just has h to the first, so we can't do anything more, but we can pull an h out of the top, common factor of it. So that'll give us h times, parentheses, 3x squared plus 3xh plus h squared. And doing that means we can then cancel our h's, the h on the bottom, out. Yes? So we have 3x squared, final answer, 3x squared plus 3xh plus h squared. So a little bit of a process, but not too bad.